Hi everyone, welcome to another week for ROS Q&A. My name is Rodrigo here at The Construct, and I'm going to be answering this question that I found on ROS Answers, in which this person is trying to increase the rate at which the Turtlebot 3 odometry gets published. And he's talking about the simulation of the Turtlebot 3, which is in a package called Turtlebot 3 Gazebo, which is a public repository that the creators of Turtlebot provide. So I'm going to show you how to do this. It's actually a really simple fix, but it's really helpful because it shows how Gazebo interacts with ROS when there's not a real robot, and how these topics that you would usually get from the real robot, in this case the Turtlebot, get published, and how to use those topics. So to do this, I'm going to go to theconstructsim.com, which is our platform, and you can go ahead and create an account if you don't have one, or log in. And we're going to go on the left here on this panel, and we're going to click on My ROSjects. So over here we can hit on My ROSjects, and we're going to create a new ROSject. And this is where I'm going to clone the repositories and show you how to change the frequency of the odometry. So we're going to choose in here in the ROS distribution, choose ROS Kinetic, because that's the distribution that works best with this Turtlebot simulation, and name it whatever you want. I'm going to name it Turtlebot 3 odometry frequency. And for the description, I'm just going to add the link for the question, and you're going to hit create. And as you can see over here, these are all my ROSjects, and this one was created, which is the one I just made. So we're going to go ahead and hit this red button, run. And while it's loading, let me go to theconstructsim.com again and just show you a little bit of our platform. And it's a really good resource for you to learn robotics. We have over 50 robotics courses, starting from ROS basics all the way to artificial intelligence and machine learning, and whatever you want to learn related to robotics. So if you guys want to learn a comprehensive way of doing robotics, I recommend you guys create an account and start learning. So when we go back to our ROSject, we can see that we have these options on the top left, bottom left. So we're going to go ahead and open up a web shell. There you go, we can make it big. And we're going to clone the repositories that we need in order to launch that simulation. So in your web shell, you can go into your simulation workspace by typing in cd simulation workspace, and then we're going to go inside our src folder, and this is where we're going to clone the repositories. And these repositories are 3. So the first one, they're in GitHub. The first one's called Turtlebot 3. So as you can see, it's made by Robotics Git, which are the manufacturers. So if you look at this address, you'll find that this repository is here. So we're going to clone this one along with 2 others. So to clone, we're going to hit this green button and copy this URL that it provides you. We're going to go back to our ROSject and type in git clone and paste that URL. And now we're gonna go back and clone the two remaining ones. So it's easy if you just go to the web search and do an underscore. It's gonna be Turtlebot3 simulations. That's the first one. And the second one is gonna be called Turtlebot3 messages. So this is the simulations one, but I'm just gonna change that simulations for messages, and that's the third repository. So we're gonna go do the same thing. Copy the URL, and in your web shell, type in git clone and the address. So now we have simulations and Turtlebot. The only one that's left is messages. So we can copy that and do the same thing. And now we have all three repositories. So we're gonna source our environment by typing cd ... and then source devel setup bash and ROS pack profile. That makes ROS go through all the packages that we just cloned in order to be able to use them. And to launch a simulation that I'm going to show you how to change this odometry frequency. First, we're going to go ahead and go and specify our Turtlebot model. So to do that, just type in export and then all caps Turtlebot3 underscore model equals burger. And now we can actually launch our simulation. Just type in ROS launch. It's called Turtlebot3 underscore gazebo. If you get stuck and you don't remember a name that you know it's in your environment, you can hit tab and you can see all of the options. So here you can see that there are all of these options that the repository is offering. So we're gonna go ahead and run the Turtlebot3 empty world, which is just an empty world with the Turtlebot. And as you can see, there's a message here, open Gazebo clicking tools in Gazebo. That means we're gonna go under this in this button right here. And you can say open Gazebo. So there you go, the simulation window opens up. And here is the Turtlebot. So this is as if we were connected to an actual Turtlebot. It's offering all of the topics that this Turtlebot would offer. And if we want to see that, we're going to go back to our web shell. You can open up a new web shell on this plus button. And you can do a ROS topic list. And here are the topics that are being offered by this simulation. And you can see that there's the IMU, and then here is the odometry topic. And the way this simulation is offering that topic is through what is called a Gazebo plugin. So we need to find out where that Gazebo plugin is defined and change the parameters in order to be able to play around with the topic. If we weren't working with the simulation, we would have to go into the publishers of the topic. But since in this case, Gazebo is the one that's publishing, we go into the definition of the Gazebo plugin. And this is found right over here. So this is the Turtlebot3 repository, and the Gazebo descriptions, URDFs, and things like that are usually stored under the description folder. And inside of the URDF folder, you're gonna find this file, Turtlebot3 underscore burger.gazebo.shacro. And this is what I'm talking about, where the plugins are defined. So as you can see, it goes through the links of the wheels and as well as the IMU. For example, here's the IMU plugin, and you can see that there's a bunch of parameters underneath the plugin that you can play around with that modifies what that plugin is publishing or what that plugin is doing, because maybe it's not a publisher. And as you can see here in this plugin, this is the controller of the Turtlebot, and you can see that it's already offering the autumn topic here. So there's a parameter where you can set what your odometry topic is going to be called, and there's also an update rate down here, and this is the key. This is what we're going to change in order to update. In order to modify the frequency of the publishing. So if we go back to our ROS checked and we want to find out what the frequency of the topic is, we can just type in ROS topic Hertz, HZ, and then the name of the topic. So you can see that the average rate is around 30 Hertz, which coincides with what I just showed you, with the update rate defined in the plugin for the Turtlebot. So we're going to modify this within our ROS checked. So to do that, you can close this and type in ROS CD, and we're going to go to the Turtlebot description folder that I told you about, and it's inside the URDF folder. So if you type in LS, you can see that this is the one that we were looking for. So to change that, just go and do VIM and the name of the file. And this is the same file that I just showed you. It's just inside our ROS checked. So we're going to go look for that controllers plugin. Here it is. And you can see that here's the update rate. So let's say we want it twice as fast. We want to know the odometry twice as fast. And this would also change actually the rate at which the command vel topic is being published. So if you type in I, that's the insert mode for Vim. So you can delete that and just type in 60 or whatever you want to change it to, and that's pretty much it. So if you you have to press escape and then ..WQ for write and quit. And now that we're back, we can close the simulation and launch it again and see that hertz, that frequency, and see if it changed. So it's killed, and we will launch it again. And just to make sure everything's okay, just hit the Gazebo button again, and there we have it. There's our Turtlebot. So if we go to our old web shell and type in the same command, if you can go with the arrow key up, you can find all of the commands you have inputted in this web shell. So we're going to do ROS topic hertz of the same topic, and there you go. You can see that the average rate is now 60 hertz, what we changed it to, this is why it's so simple. But it's important to know where this topic is coming from, so you know where to play around with it. So, and those things are, like I said, are defined inside of the plugins that you can add to your models in order to offer topics. If you want a tutorial on how to implement those plugins and how they work, I recommend you go to this page. using Gazebo plugins with ROS. I'll put the link in the description, which is a great overview on how these plugins work in case you want to add more or add a sensor plugin that the Turtlebot won't have, things like that. So this is a great tool for you guys to learn. And that's really it. That's how you change the frequency of the odometry in a plugin, in this case for the Turtlebot 3. I hope you guys enjoyed this video, and I will see you guys next week for our next video. Thank you very much, and bye-bye.